expression of torque acting on an electric dipole on an electric dipole in an uniform electric field. You do not have the case of non-uniform, that is not in your syllabus of GGS IQ. Now see one thing. In a uniform electric field, that means the electric field lines are separated by a uniform distance. The first thing is this. The electric field is separated. Now this is a dipole like this. The minus charge is here. The plus charge is here. This is making an angle theta with electric field. Now consider an electric dipole in an uniform electric field E, making an angle theta with the field, making an angle theta with the field. Now the force acting on plus q, is F due to plus q is QE vector, and the force acting, let me write it down, acting on minus q is F due to minus q, that is minus QE. That means if I draw in the figure, the force in this direction is FQ is QE, and on this it is F due to minus q is minus QE vector. Now the net force or the total force, whatever you want to say, net force F net is equal to F due to plus q plus F due to minus q. This is equal to QE vector plus minus QE vector. This gives you 0. So net force being 0, so there is no translation. This is the thing, right? Now the point comes is, see, the torque due to, let me write torque, so there is no translation. The torque, the rotation effect, I mean to say, torque due to electric dipole, right? Let us call it is torque conservative. Let us call it torque C, torque conservative. This is equal to the perpendicular distance of the line of action into F, either of the forces. Now let us take torque conservative is equal to, now the perpendicular distance, let us see here, let us see in the figure. Let us draw the figure again. The figure was like this. The electric fields are in this direction. The electric fields. This is here. This is making an angle theta here. This is one force here. The other force is here. So the perpendicular distance here, it is like this. This is theta. This is 90. Sorry, this is 90 degree. If this is theta, then this is theta with a corresponding angle. This is 90. This much angle is 90 minus theta, and this angle is theta. Let us make the figure big. Let us make the figure big. You will understand them. इस figure को थोड़ा बड़ा बनाते देखते हैं. Now this is the way it is, right? This is our dipole like this. Now the force in this direction, in this direction, the force in this direction is F is in this. Minus Q is here, plus Q is here. This is the way it is. Now this is making an angle theta here. Let us take the perpendicular distance, this distance. This is 90, this is theta. Now see one thing. This is also theta because this is corresponding angle. This is a transversal. Last time मैंने पढ़ा था transversal. This is corresponding angle. This is 90. This is 90 minus theta. This is 90. So this is theta. This total distance is 2a. 2a. So what is this distance? What is this? Use Pythagoras theorem. This is R. This part is R perpendicular. This part is R perpendicular. Try to understand. This is R perpendicular. This R perpendicular is nothing but sine theta is equal to R perpendicular upon 2a. So this is R perpendicular will be 2a sine theta. Got it? So R perpendicular, and this is in the see this is the x-axis and this is your y-axis. This is your y-axis. So this is your x-axis and this is your y-axis. Now R perpendicular will be 2a sine theta j direction. It is in this direction. In this direction it is. This direction. Cross q e I cap. Because the positive charge is in this distance. No problem. Now this is the torque. Either of the force, either of the charge, and then either of the force you can take. Now this torque. See one thing. Now you make this I, J, and K, right? J cross I is minus K. So torque conservative is equal to minus 2a Q sine theta. Wait a minute. E sine theta. E sine theta. E sine theta. See, it is K cap. K cap. It is in the downward direction. See how it is. See. Now I explain you. Wait a minute. The electric dipole moment is electric dipole moment is P equal to Q into 2a. Q into 2a. So just this is torque conservative minus PE sine theta K vector. Now try to understand why this minus. ये minus किस लिए है or why this is the K vector. Now see, the electric field is lying in this direction, in the x-axis. The dipole is in this direction. P vector is in this direction. Now you're rotating, the dipole is rotating it in this sense. In this sense. Got the point or not? The dipole is rotating this in this sense. It is going to go in this manner. The electric dipole, this is going to go in this manner, this is going to go in this manner. So it's going to take a rotation in this manner. So if you curl your finger, let me write down here. If you put your right hand, curl the fingers of your right hand from P to Q, P vector to Q, E vector, sorry, not Q, E vector to vector, then the thumb would be directed inwards, inwards, that is into the plane of paper, that is into the plane of paper, into the plane of paper, that is, it is going to go in this direction. Curl your fingers like this, and the thumb is going to go in this direction, that is minus K. That's why this minus sign and this K. इसीलिए minus sign and K है. Curl the fingers of your right hand from P to Q, then make an angle theta, then the thumb would be directed inward, that is into the plane of paper. That's why this minus sign. Got the point or not? Now, this torque, conservative torque. Now listen very carefully. I'm talking about conservative torque. Now, this is conservative torque. Is very carefully you listen this. This is, listen, this is basically, you can take it in this sense. You can write it as your minus P cross E. Just see one thing what I'm trying to do. This is the conservative torque. This is the conservative torque. Due to the electric field, this torque is due to electric field. Keep it in your mind. This is due to electric field. Rather, instead of writing minus, I can write this. Forget about this because the minus k will get absorbed here. Minus k will go there because when you rotate it, this is the work done due to electric field. This is the conservative. Now let's see the external torque. That is the work done by you in rotating it. The external torque applied is equal to minus torque. This very simple. This is minus P cross E. And what is P cross E? P cross E is minus of minus P E sine theta k cap. That is nothing but torque applied is P E sine theta k cap. Torque applied. This is the torque applied. So mostly you don't have to confuse this. One is due to the electric field. This is due to electric field. Torque C. Torque C is the torque due to electric field. Electric field. Torque applied is the torque due to your applied forces, due to electric field, or I should say conservative forces, due to conservative force. Conservative force. Wait a minute, let me write it down clearly. Let me write it down clearly. Due to electric field, or conservative force, right? And due to external, or you can say applied force. This is the story. This two difference you must remember. What you are trying to do. The applied force is this. Applied torque is this. Now the problem is, you will ask me, which is the right expression? See, you have seen in books, it is written torque is equal to P cross E. That is conservative torque due to the dipole. This is the conservative torque due to the dipole. But now let me make things very clear to you. Let's make things clear. See, what expressions I have found out. Torque conservative I found out to be P cross E. Vector, this is nothing but minus P E sine theta k cap. Torque applied is nothing but minus torque of C. This is nothing but minus P cross E. This is nothing but E cross P. Why? Why this? Because A cross B in a vector product is same as minus B cross A. That is the idea. And this is same as P E sine theta k cap. Now this difference you must understand. What you are trying to use is the torque that you are using due to conservative forces, or that is due to the electric field, or you are trying to find the torque by the application of an applied force. This has to be very clear. Otherwise, there is no you won't be able to do problems on this. This applied and this conservative is very, very important concept.